Hello, here we are, Unit 3. This is our notes. Ready? Here we go. Our objective, sorry for the blurriness, is to simplify and identify undefined values of rational expressions. So we're going to simplify rationals. Consider for a moment the following expressions and simplify them in a manner in which you were taught in lower grade levels. So 20 over 45, what's the common factor there? What's the greatest common factor, right? We could divide the top and bottom by 5, but what we're really doing is we're saying 4 times 5, and we're changing 45 into 9 times 5, and we're dividing out the 5s to get 4 9s, right? Now here you can multiply across to make it a big number, but what I like to do is rewrite 15 as 3 times 5 and rewrite 10 as 2 times 5 and 6 is 2 times 3 and 7 is prime. Now what factors are the same? So, and why can we cross them off? 3 divided by 3 is the number 1. 2 divided by 2 is the number 1. Can we cross off the 5s? No, because right now it says 5 times 5, which is 25 over 7. Uh-oh, what do we do with the division? Do you remember? We need to rewrite it. So we have 15 over 6 times the reciprocal. You flip it. And let's think about our common factors. So in 15, well actually 15 and 6 have a common factor, and 15 and 20. Let's see here. 15 and 6, what's the common factor there? 3. So the 3's divide out, and we get 5 over 2. And 12 and 20, you could divide those by 2. So we have 6 over 10, which means you could have divided by 4 to get 3 over 5. Now I have 5s that can divide out, and the final answer is 3/2. Do you agree? Okay, awesome. Okay, D, here we go. Oh, we have 3's. Let's cross those 3's off, and the answer is 15 over 10, which is, what is that? Divide by 5, right? Excuse me, so divide by 5, so we have 3 over 2. Final answer. Is that correct? No, no, never. No, no, never, never. No, no, never, never. Why is that not correct? Let's take this. What is 15 plus 3? 18. And what is 3 plus 10? 13. Is 18 over 13 equal to 3 over 2? So if these aren't equal, which one's the correct one? Well, it's not this one. Okay. This one is the correct one. What are we doing over here? We are dividing out. We're dividing out factors. F-A-C-T-O-R-S. Okay. Do you see how that says a plus sign? Plus 3, plus 3. This is not a factor. So what is a factor and what is not a factor? So a factor, ready, is a term that's being multiplied. So if it's being added, right here, see how that's being added? Then it's not a factor, so we cannot cancel it. All right, hopefully you've seen that, and that's review. So only factors that are common to both the numerator and denominator are the only things that can be canceled in an algebraic expression. Factoring is the first and foremost operation that must be performed before we simplify rational expressions. What's a rational expression? It's a fraction. These are like going to be my messiest notes ever. It's a fraction with variables. What? Variables. So the word fraction usually just means numbers. Oh shoot, blurry. Rude. I apologize. Okay, there we go. You ready? So, you ready? Step 1. Am I ready? I don't know. It's a Monday morning. Factor first. That's when I'm recording this video. I don't know when you're watching it. What year are you watching this in? It could be like 2036 or something. Factor first. Ready? What's our common factor here? What's in the 2x squared and the 6x? 2x. So when we factor that out, we get 2x times x plus 3. And how do we factor x squared minus 9? X plus 3, x minus 3. Do we have a factor in the numerator and the denominator that are the same? Yes? So watch, this is what I've seen. Instead of going you could say, you know what, this cancels to the number 1. And we like cross it off, but we make a 1. Final answer, 2x over x plus 3. Can we cancel those x's out? No, no, never, never. No, no, never, never. Let's do it again. Greatest common factor. Always start with the GCF. Oh, that's it? Yep, that's it. Always start with the GCF. Now, if I took out a negative, this needs to be a negative times a positive will get me back that negative. Oh, look at this sneaky, sneaky, sneaky. Oh, my lights. Oh gosh, this is almost the worst video ever. Why is this sneaky? That's a sum of 2 cubes. What's the cube root of x cubed? X. What's the cube root of 8? 2. Then do you remember how to build the second one? So square the x, put it in the front, square the back, put it in the back, squish them in the middle, but we need a minus sign. And I didn't have one, so it must go here. Sneaky. This is a sum of 2 cubes. Remember that? Remember that formula? Do we have a common factor in the numerator and denominator? Yes. So how do I make my number 1? I don't know. So it doesn't look pretty, so I'll just cross them off like that. Can this be factored again? No. How do I know? Well, we wouldn't make you memorize a formula that could be factored again. You know what I mean? Like, if this is already the formula, then it can't be factored again. Final answer. Now, let's see here. Does this have a common factor in the top? No, but it has 3 terms. So anytime you have 3 terms, it will always go to this. And we know the denominator is x plus 5 times x minus 5. Now the numerator, what multiplies to get x squared? And what multiplies to get negative 15 but adds to get negative 2? So 1 and 15 or 3 and 5. I think it's going to be 3 and 5. But they have to add to get a negative. So we're going to make that, and I'm going to check it. I'm going to check that. I know x squared plus 3x minus 5x, and then a negative times a positive would be negative 15. Awesome. Okay, guess what? You're going to try these, and how about I give you the answers? So, final answers. Ready? X plus 1 over 3x. What? 4 terms. What do you have to do there? Factor by grouping. F factor by grouping. I just made that up. 1 over x squared. I made this up, I didn't make up factor by grouping. That would be cool. I bet I'm not that cool. Okay, those are the final answers, so you're going to try those. Let's see what's on the back. Ah! Oh, that's funny. Okay, this is on the back. One thing we have to remember is that rational expressions cannot have a denominators that are equal to 0. What? Have you ever heard that? Have you ever heard that dividing by 0 is okay? But, sorry, 0 divided by something else is okay, but something divided by 0 is no. Any x value which makes the denominator equal 0 are called restricted values. Say restricted values. For each of the 6 rational expressions from the page before, rewrite the factored form of the denominator only, then find the restricted values of x. So we're going to set, ready? What does this all say? We're going to set the denominator equal to 0. So the denominator from a, before you cancel, the denominator from a was this. And if we set this equal to 0, then x equals negative 3 and 3, right? What that means is that this cannot equal, you cannot plug those x's in. Those are the restricted values. So let's do this one. X plus 2, this was that cubic. I don't know we haven't solved this. I got to think about that for a minute. X equals -2. And then that, I wonder if we need to use the quadratic formula, because this can't be factored. So if you use the quadratic formula, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Do you see how we're going to get 4 minus 16? And that's the square root of a negative. So that's going to be no real solution. Okay, so the only restricted value is here. For part C, what was our factored form of C? X plus 5, x minus 5 equals 0. So our restricted values are -5 and +5, like that. All right, I want you to try these, but this is kind of easy, so I don't really want to give you the answers. What's the big idea of these messy notes? Can you cancel something next to a plus sign? No, no, never, never. What do you have to do first? Factor first. Always check for a greatest common factor, right? Once you have a common factor in the top and bottom, you can cancel those out. We try to not say cancel, we try and say divide out. This is a review of all factoring. I want you to try these. These are the answers. What else? The denominator can't equal 0. So what we do is we set the denominator equal to 0 to find the x's that we can't use. That's what we did here. Okay? And then you're going to practice this, and we will go over the answers when you're done. Thanks for watching. Good job. If you have any questions, post them in the comment section of Google Classroom.